Hi everyone. So in this video, I'm going to show you a very simple example of reducing the block diagram systems to a single transfer function. Here we are provided with the block diagram system in which we have 1, 2, 3, 4, 5, 6 blocks. Each of them is a transfer function, and the aim is to find the equivalent single transfer function from R here to C here as the output. And in this video, in this short video, I will explain you how we can do it. So here, by looking at this function block diagrams that we have here, we can see that we have a loop here. So this is one of the inner loops for which we can easily find the equivalent transfer function. After replacing it, we will have another simple feedback loop, including H2 and the result of the previous previous step, for which again we can find the equivalent transfer function, and the result with this H3 will form another feedback loop, as we can see here, negative feedback. Again, it's easy to find the equivalent transfer function, and the resulting transfer function will be in series with the G1 transfer function, which will be multiplied with each other, and this will give us the overall results. So before going forward, I would like to remind you some of the basic rules that we have here for simplification of the transfer functions. The first one which will be used here is the transfer functions in series with each other. So if we have two G1 and G2 transfer functions in series with each other, the resulting transfer function will be the multiplication of those two, G1, G2. Another very important rule which will be used here again is the feedback loop. So if we have G1 and H1 configured in the feedback setup, negative feedback here for example, the resulting transfer function will have G1 in the numerator, and in the denominator it will have 1 plus G1 times H1. So G1 which is in the forward pass and H1 which is in the feedback pass. G1 H1 will be the equivalent of the feedback loop. Here, pay attention to the sign of the feedback. If we have minus here, or the negative feedback, we will have plus sign here. All right, so let's go forward. As the first step, I will simplify G2 and G3 here. So they are in series with each other. G2 and G3 will result in G2, G3 transfer function, which is in a feedback loop with H1. So we will have this situation here. G2, G3, and H1 in the feedback loop with a negative. The resulting transfer function will be G2, G3 in the numerator and 1 plus G2, G3, H1. I will call this T1. So here we have T1. Now I need to find out what the this is T1. I need to find what the T2 will be, which is the result of simplifying the T1 in a feedback loop with H2. So this is what we have. T1 and H2 in a feedback configuration where we have a positive feedback, as you can see here. So the result here will be T1 over 1 minus T1 H2. And if we replace T1 with this expression, we will get G2 G3 over 1 plus G2 G3 H1 divided by 1 minus the same expression G2 G3 over 1 plus G2 G3 H1 times H2. And if you simplify it, we will get this expression G2 G3 over 1 plus G2 G3 H1 minus G2 G3. Here we have G2 G3 H2, which should be called as T2. This will be our T2, and T2 is in a feedback configuration with H3. So if we move on, we will have this configuration T2 H3, and the sign of the feedback is minus. So we have a negative feedback here, and the result of simplification here will be T2 divided by 1 plus T2 H3. So again, pay attention to the sign of the feedback. If we replace T2 with the expression from here, what we get is like this. So we have G2 G3 over 1 plus G2 G3 H1 minus G2 G3 H2 divided by 1 plus the same expression G2 G3 1 plus G2 G3 H1 minus G2 G3 H2 times H3. And if we simplify it, we will get G2 G3 divided over 1 plus G2 G3 H1 minus G2 G3 H2 plus G2 G3 H2. So this is our T3, and the resulting T3, which is here, so this is called T3, is in series with G1. So this is our overall function blocks. We have G1 here, and then T3 here. The input is R, the output is C. So T, which is equal to output over input, C over R, will be equal to T3 times G1. And if we replace T3 with the expression from here, we will get T of S equal to G1, G2, G3 divided by 1 plus G2, G3, H1 minus G2, G3, H2 plus G2, G3, H3. And the whole thing, the whole block diagram is reduced to this situation. So we have C of S and as the output, R of S as the input, and T as the overall transfer function. All right, so that's all for this video. I hope this would help you in understanding how to reduce the block diagrams into the single transfer function. Thank you for watching and see you next time.